The third video in our series of beginners radio navigation for Flight Simulator, and in this video we're going to look at something called a VOR, which stands for VHF omnidirectional range. And don't worry, everyone just calls them VORs, and the VOR is the most sophisticated of all of the radio navigation beacons. So until you start using GPS, this is as good as it gets. And we've already looked at an NDB, and an NDB is non-directional. It's very simple, and really the only help that you get in the cockpit is an arrow pointing towards where the NDB is. Now that's great, but that's quite hard to actually navigate with. Imagine you were trying to approach somewhere at a heading of, let's say, 30 degrees. Well, if you're flying and the arrow is not pointing at 30 degrees, you've then got to do some kind of maneuvers to try and work out, do I turn left or right? How long do I turn left or right for until I turn back on course? And you could end up playing around a lot with your flying just to try and get a heading of 30 degrees. So an NDB isn't really designed for accurate heading information. And the distance measuring equipment, which we looked at in the last video, is also quite a basic tool. So it's useful. It's very good with any kind of navigation in an aircraft to have a number of pieces of information just to make sure that they all agree. If you only rely on one piece of information, but you've tuned the radio wrong, or you've set your heading wrong or whatever, then you can end up lost, and you don't want to end up lost. So a VOR gives you a lot more information, and you can see here on the slide, this is a picture, ignore the bit in the middle, but this bit here is the VOR, and you can see it's fairly extensive, fairly big, and fairly expensive. So you're not going to find these, or not many of them, in the middle of a desert or in the middle of Australia because of the complexity. But in high traffic areas, which is most of the UK, certainly in the southeast, we'll look at in a minute, there are lots of these because they provide that accuracy of heading, which means that when you're trying to do an approach or a departure, when you've got hundreds of planes an hour moving through the area, you really want planes to be flying exactly where you want them and not kind of, 10 miles to the left or right of something. So that's what it looks like in real life. On a map, most of the time, it will look like this. So you see it has a compass feather painted around the VOR. And as I mentioned before, this is the symbol for VOR with distance measuring equipment. And that is because in the UK, all but 2 VORs have distance measuring equipment located with them, because the DME part is, I guess, much more basic and cheap. Why not put one in there as well? One of the 2 examples of somewhere that has a VOR that doesn't have DME, you can see here at Cranfield Airport in Milton Keynes, what's that, Bedfordshire. You can see here that it's got the hexagon in the middle, but it doesn't have the box around it. So that's unusual, and I'm not sure why it doesn't have DME there as well. But like I say, there are only 2 places that you'll find just a VOR. And everywhere else VOR and DME are together, so you probably can't quite see it here, but that's a box and a hexagon in the middle. Now VORs all have a 3 letter code, and almost always it's just the location of the VOR. So this is Berry Head, which is BHD, Brecon is BCN, Seaford is SFD. You kind of get the idea. And those 3 letters, again, are available via Morse code if you want to listen in and make sure you're pointing at the right VOR. And they also have a frequency, so 112.05, you can see here. You'll notice that's a lot lower frequency than the NDB, which means these don't have quite the range. An NDB can have a range of several hundred miles. They used to be used to navigate across oceans and things like that. A VOR is more used for accuracy over shorter distances. So the frequency is lower, which means the range is lower, but it also means that you can't tune your nav equipment to an NDB, and you can't tune your auto direction finder to one of these frequencies because they're in different ranges. And there's a couple of ways that we use a VOR. So I'm going to show you the basic operation of a VOR. And what you need to know about a VOR is because it has all of these different beacons, different antenna around the center, what happens is a signal is sent out in rotation in a way that means that any aircraft that has receiving equipment can actually tell in which direction it's heading towards the VOR from. So it doesn't just say it's straight ahead, it can say, well, it's straight ahead, but you are currently at the 90-degree position or the 360-degree position or whichever direction you're going into. And we call these radials. So we would say if you were kind of at the 90-degree radial, it would mean, imagine we're facing north here, it would mean you're somewhere over in this direction here. And the reason that's useful is within a few degrees, you can basically go from VOR to VOR, get a very accurate fix, and we'll see why that's kind of important in a minute. But let's just pop over to X-Plane. And here what's happening is I've taken off from Shoreham again, and I'm flying towards Seaford. I'm just going to pop this out so you can see a bit more clearly. So I'm kind of heading towards Seaford, and let's imagine, for argument's sake, that I've decided on my navigation I'm going to fly into Seaford VOR at a heading of, sorry I can't see it there, 153 degrees, and then once I get to Seaford, we're going to move onwards and head down towards Agoti intersection, which is down here. So in order to fly at a particular radial, what we do is, let's just pop that way. Obviously, we tune in to the VOR that we're interested in. In this case, Seaford is 117.00. And because I want the 152 radial, you'll see here that using this little OBS switch, you can basically set the radial that you're interested in for the VOR that you're approaching. Now, what we've got to be very careful of here is it depends on whether we're arriving at or departing from the VOR as to what heading that we need to set on here. And it probably helps to explain it if we think about it on a map. So let's just zoom in here towards Seaford. Now, if we imagine this line here, just for argument's sake, that is 330 degrees on the compass, and that's fine. But what you've got to imagine is if I'm travelling towards the VOR, I'm not actually travelling at 330 degrees. I'm travelling at 150 degrees. Yeah? So I'm actually moving in that direction. So when I'm going towards a VOR, I need to, depending on how you think of it, subtract 180 degrees from the heading, add 180 degrees and subtract 360 if it goes over 360, or just to look at a compass and work out that if I come in at 330, I need to go at 150. If I come in at 30 degrees, I need to leave at 210 degrees. Obviously, if you're flying away from the VOR, then that's just normal. That's going to be, if I'm flying in here, I would need to set my heading, my, sorry, what do you call it? Your heading bug on here to be the opposite number. But once I've crossed the VOR, then it makes more sense because then I would be flying at 150 degrees. So that will make more sense as we're flying along. But like I say, I've set this to 152 degrees. And if you notice here, I've actually got, if I just slide down a second, I've got the autopilot holding my heading. I'm just going to turn it off because I don't want it to hold my heading for me. And I've got it off. Anyway, here's my heading bug, and my heading bug's set here. Now, if we look at the line, what this line is telling us, because this is a VOR, it's telling me, let me pause before I go too far, it's telling me that the line, the radial that I want, which is the solid line, is off to my right. Now, if I was very close to the VOR, I wouldn't really care too much, because give or take a couple of degrees, especially for a visual flight rules flight, we're not usually bound by specific headings. But in general, obviously, if we've decided we're going to go fly a certain heading, we should try and stick to that heading. And this is how the indicator looks. Now, different indicators look different. So some of them on the older planes, they had a thick arrow, and the center section of the arrow moves to the right or the left. And that's slightly different to this indicator, because if my memory serves me correctly, the middle part of the arrow that slides to the right or the left is a bit like your plane. So if the middle bit slides to the right, it means that you are too far to the right of the radial and you need to go back to the left. So you need to learn what your indicator looks like in your plane. Obviously, if you have a glass cockpit with a big screen in there, goodness knows it could look like anything. It's probably got a big green line on it or something. So, learn your heading. But in this case, it's telling us that I'm flying too far to the left of the radial that I've set here. Now, if I actually move this round, that needle's going to move, because if I kind of say, well, actually, now that I'm on the, whatever I am, 155 radial or something, if I set this to 155, then that line will come back to the middle, because obviously I'm approaching at some angle or other. But let's just assume that I need to be flying at 152. I think that's set to 152, but problem with these is it's quite hard to see sometimes. So 152, I'm coming at the wrong angle. So what I'm going to do is I'm going to turn slightly to the right. Now, because I'm only 10 miles away, I'm going to probably have to turn fairly abruptly. I maybe go, 20 or 30 degrees to the right by moving my heading bug. And then as that line moves back into the middle, I will then turn back towards 152. So if I unpause it, it would be nice if it told you what the heading was. So I'm just going to fly around. Like I say, the autopilot is holding my altitude for me, which is good, because otherwise it's going to get all messy. And what's this there? This is actually how the airliners fly. If you were interested, they kind of often fly by using the autopilot and then just using the controls. So notice this is moving across, because I'm now coming back towards the right place. Now this turns quite sharply, and so if I now go back to the 152, now the heading bug, you can see more clearly, that's 150, 12. It's a little bit clearer. See, now I've gone a little bit too far here. Now it doesn't necessarily matter if I drop the range down a bit. It's now telling me I'm a little bit far to the right now, and again I could, if I wanted to, go a bit that way, maybe not by quite so much, and then again as that line comes across, then I can go back in. Now at some point, I'm going to accept if I don't use the autopilot to fly the nav, because I can hit that button and it will actually follow this. That's kind of cheating. I just want to show that if we move over a little bit, then that line will slowly move across, because we'll get back to where we should be, and then we should be able to, in a few moments, go back to 152. So, nearly there. Obviously, with experience, you would learn how long you need to wait before you turn, and how steeply you need to turn, and things like that. But as you can see there, that's fairly good now. Pretty much flying on the 152 radial, or according to this, I'm on the 150 now. But never mind. So you kind of get the idea of a VOR. Now the interesting thing here is that's really quite accurate, because if I'm even just 1 degree out in terms of a circle, then this thing is going to pick it up and it's going to show me that I'm 1 degree out. So even at this point, it's kind of drifting out a little bit. I'm just going to hit the nav for a second. I'm going to let the plane find its own way. But the important thing here is I'm getting much more kind of quick feedback as to when I'm going off course. If I was flying this with the auto direction finder towards an NDB, well, for a start, if I was flying away from the NDB and the arrow was pointing backwards, you know, can you imagine if you're trying to keep the arrow pointing at, say, 21, if it moves one way or the other, you're going to have to correct your course, and you have to do what we just did by kind of bending and bending back and bending and bending back. But in terms of flying, we can use the autopilot to fly nav if we want, or we can just fly the heading using the heading indicator here. Notice that because this is really quite close now, the autopilot's kind of struggling to get back on course. But once we get to once we get to Seaford, I'm then going to show you what it looks like when we use two VORs to triangulate. So one of the other great things is you can see we've got this tuned into the Seaford VOR. If I just cheat a bit, there we go, going in the right direction. We've got a second indicator down here. Now this indicator doesn't have a glide slope, so you can't use it for ILS landings, but you can use it for triangulation. And so what I'm going to do is, if I just leave that flying for a second and I bring up the map, you can see here that we're flying here, we're very close to Seaford, and I want to head down to Agouti just to show you. Sorry, that's Drake. Oh, it's Drake, sorry. I'm going to fly towards Drake from Seaford. Now notice that every intersection on here, if you switch your mode to IFR, every intersection is basically a line from a VOR and a line from another VOR. So if I zoom in here, I can see that this is 193 from Seaford. So once I get kind of pretty much over Seaford, I'm going to set my heading to 193, and I'm going to fly out from Seaford VOR, and then we'll show you how we actually get a fix off. In this case, we'll probably use Goodwood, which is over here, and we can triangulate this intersection without using GPS. If you've got GPS, then obviously the GPS knows. So we'll just now let's go 3. That's 180. That's 90. I'll just use my heading on here to tell the direction I'm going in. On Microsoft Flight Sim, so to remember, if you hovered over it, it told you the heading you were flying. But okay, so we're flying hopefully 193. Great. So we're flying at 193. So let's go back to the map again. We're kind of heading out on this line. I'm not actually worried too much about flying exactly to the intersection, because otherwise I'll be kind of mucking around all day. What I really want to show you is how we could triangulate a position from another VOR. So rather than waiting for us to go all the way to Drake, let's just pick a point, let's say here. Let's imagine we've got an intersection that we need to hit, and let's imagine we're then, say, turning right to go to Notgi intersection. By the way, you might not know this, but these have these little funny names. Although the letters are random, they're designed so that it can still be read as a word. So you're not going to have like FFX, GG or whatever. They're all going to have words like, you know, like undone or Nivco or you know, Inkek and all these sorts of things. So interesting fact. But let's imagine we have an intersection here, and let's imagine that that intersection is from Goodwood, let's say, what are we, 90, 120, 130, 140, 130. Let's take the 130 intersection from Goodwood. So, Goodwood, right. So I'm going to tune my nav2 radio to Goodwood. And what did I say? 90, 120, 130. And I'm going to set a heading of 130 on this. 130 is 90, 120, 30. So as expected, let's just look at the map again. We could actually tune this to be 193 as well, because that should move, so that should be 290. Yeah, like I say, it doesn't really matter too much. Let's just say we're doing that. So as expected from the map, the radial that we're interested in is currently to our right. Now, when you're not flying in line with the radial, you've got to be a little bit careful about what that information is telling you. But effectively, at the moment, that whole radial is across to our right, which is why that second indicator here, so that's tuned in down here into nav2, is showing over to the right. Now what will happen is, when we arrive at the intersection of this and this, that needle will move across to the centre. And once that needle's in the centre, so we're assuming that this is going to stay straight, and I'm going to probably hit nav to that just to actually make sure we're getting a nice straight line on that. Yeah, that's fine. Leave the autopilot to do its thing. Yeah, so once we get down to 130, that needle will come across, and that will be saying, right, you are now at the intersection of 130 and 190, or whatever it is that we're flying. So obviously, if we had distance measuring equipment, we might know how far away that is. So we could say, oh well, we know it's going to be 20 miles away from Seaford VOR. In which case, we don't have to sit here staring at this gauge, because as your instructor will keep telling you, VFR is about seeing and being seen. We need to keep our eyes out the window. Is there anybody here? Is anybody here? Am I going to crash into anybody? Scanning the instruments. Am I straight level? Am I flying, at fixed altitude, etc., etc. So we're flying out here, and we just look at the map. 130. So it should only be a couple of more miles, and we'll see that happen. And then what we'll do, just for kicks, is we'll make a turn afterwards, and let's say we will go, let's say maybe 275 degrees. So we could do that as a heading if we wanted to. So if we chuck that to, I'm not sure where that's that autopilot's not doing what I thought it was supposed to do. So let's just take 275 for example. So we're tracking 196, whatever, don't really care too much what we're tracking. And all we're going to do is, when we see that line come across to the middle, that's when we know that we're intersecting whatever it is we're flying now, 190 and the 130 of Goodwood. So let's wait for that to happen. Looks like it's moving. Can you see that moving now? Well, you won't be able to. Just zoom in. So you see that dot here? So we're moving very slowly. You'll notice here there's a little indicator which shows you whether you're flying away from or towards the VOR. It's kind of fine most of the time, you should hopefully know that, but again it's just another piece of information. If you're going from, it's kind of fine. If you're going to, it's a reminder to think, right, I don't want this number, I want this number, so that's just kind of a little reminder. But you can see here that this is now moving across, which means that Bembo, in fact it's like Bembo on the map. There's Bembo. So Bembo intersection. Now I haven't specifically targeted this, so I'm not sure whether that's actually where 130 meets 190, but you don't know, it might be. So a needle's coming across, and not 100% convinced about idea what this autopilot was doing. I probably should have read up on it before I started playing. So I might just switch back to heading for a second, just to so it's at least doing what I know it's doing. So again, we're still flying south. Now notice here that this radial is basically in front of us here. So as we're approaching it, that's moving across. And then obviously if I knew how to use the autopilot properly, and if it was actually flying the nav, I'm not sure what I haven't pressed, but it don't seem to like it very much. Yeah, this would normally be a straight line, and then that will come across. Oh, maybe Bembo is exactly where I accidentally planned to fly to. So as we approach Bembo intersection, that line presumably goes right through there. So like I say, all of these intersections here are just radials from VORs. You won't necessarily know which radial they are without getting a ruler out. But here we can see, look, we're pretty much over Bembo, and that line is now pretty much in the middle. So let's say we now take a swing round to the west, and then while that's doing that, we could, in some ways we could go back to, mid VOR. So now that we don't need CFID anymore, we could tune that to our nav1. So what happens if you're flying VOR to VOR is you're kind of using nav1, then nav2, then nav1, then nav2. So if I set nav1, and I'm probably going to need to, so that's found mid. I'm on the 148 radial. Now remember, I'm flying to 148, so 148 will be 328, which is basically what I'm doing here. So I think if I hit nav now, that should basically twist me around a little bit and get me to 328. Help me track back to mid again on that. So what this is doing now, it's going to bring me back round towards a radial up here. It's probably not this one, probably the next one down. But you see, it's kind of really straightforward, because all you've got to do is tune in the VOR. Most modern equipment, it will identify it. So if you hit the button there, you can hear it beeping. So again, that's just beeping out the Morse code to make sure it's the right one. Nowadays, that kind of stuff is maybe less important now we've got these big screens. We kind of get a bit spoiled and we don't have to do it anymore. But these sorts of things are, the basics of flying VOR to VOR is still very much relevant, and we still need to learn how to do it. One of the main reasons why that's important, hopefully you've got enough idea of flying VORs. If we just head back to here, a reason why that might be important is, imagine that you're doing, I think I talked about this the other day, flying from Kemble to Kidlington, or Kemble to anywhere up here. You have this big, basically controlled traffic zone. It's Bryce Norton RAF base. And the problem that you have here is, although you can use distance measuring equipment to work out, when you're, say, 10, 20 miles away from here, in terms of actually getting around it without going into it accidentally, without cutting a corner somewhere, you're not really going to be able to do it with an NDB or with distance measuring equipment. But what you can do, although you can't really see it on this map because there aren't any VORs close by, is you could actually use any of the VORs that are around here. You could take a heading to, say, Honolly VOR, which is towards Birmingham. And then you could say, perhaps, when I'm then 40 miles south of Birmingham, I can then maybe turn to heading 90 degrees and go across here, pick up another radial of the Honolly VOR here to then go down towards Kidlington, and then do the final approach. So you could just do that across the radials of one VOR. You could go to a VOR in this direction, different VOR in this direction, because there are so many of them that you have about 50,000 different intersections that you can choose from. And of course, it's up to you to do that. You just need to plan it out in advance and work out, right, what are the frequencies of these VORs. You can have your map with you, that's great, but plan your route, draw it with your little marker pen on the map so you can work it out and say, right, this is 110 or whatever, this is 150 or whatever it might be, and you can get really quite accurate, even places in southeast. The southeast of the UK, where London is, where you have very short corridors, very narrow corridors of uncontrolled airspace. And to get through them, you really need to be able to fly that VOR route and to, either get the autopilot to do it or to fly it yourself. So that's kind of all there really is to VORs. Very briefly, a TACAN is a military version of a VOR. It does exactly the same job to a higher accuracy, but unless you have a military plane, you cannot receive a TACAN. But if you remember from what I said before, all TACANs have distance measuring equipment. So if you were near Bryce, you wouldn't be able to get any VOR fix on either of the NDB or the TACAN, but you could get distance measuring off of Bryce Norton TACAN. So that's what a TACAN is. Very rarely you have a VOR and a TACAN and distance measuring equipment all in a single place. Very rarely. They're called VORTACs. I think you'll notice that on the on X-Plane, I think this is a symbol, or maybe it's that symbol they use for all VORs anyway, which is slightly incorrect. But again, VORTAC, you don't need to worry. All you need to know is you can use it as a VOR. You can't use a TACAN unless you have a military plane. I don't know if the military planes in X-Plane use TACANs or not. Otherwise, VOR, compass heading, tune into it. You've got the frequency here, 112.05, whatever. Tune into it and use the line here to tell you, am I straying to the right or to the left? And remember, the solid line is the radial coming off the VOR. So this is telling me that I am too far to the left of the radial that I've selected using this OBS switch. And if I bring the map up, you can see that I am too far to the left of the radial. So that's hopefully enough information and you're not getting too bored. In the next video, I'm going to look at approach charts and precision approaches, because they're kind of one of the really fun things to do. And the cool thing is you can practice them in a Cessna like this, going much more slowly than you would in an airliner. So if you're interested in precision approaches and approach charts and what have you, then look out for the next video. Otherwise, questions or comments as usual, please